ultraviolet light, so you can't see that. It's when it hits the coating inside the tube that those chemicals are excited and becomes the light that we see. Okay. The problem is the ultraviolet light is still escaping, and that gets back to what I mentioned before about people getting the rashes, because it's the ultraviolet light that gets through. I showed you a little bit here. The light quality, LEDs are actually a full spectrum, fairly close to what our eye's sensitivity is. The benefit of this is though, when you start looking at paint colors or clothing colors, you know, you go shopping, oh, this looks good, you get it home, oh God, like what is this? Like this isn't anything like how I want it, right, or what I expect it to be, because of the different lighting conditions that you get. And it's going to be, it's not a perfect solution, you're still going to have some of that, but you're going to have a lot better. On the graph here I've got examples of different light sources, fluorescent light, and if you were to look closely you see all the bumps in the colors and stuff like that. I also made a little homemade spectrometer, a little toy, that you can actually look at. It just has a slit in one side, but I've got this plastic on the other side that's about 1,000 lines per inch, and it breaks up the light spectrum. So I can demonstrate to you after that if you look at a compact fluorescent, you'll see a blue, a red, a green, and an aqua. Like boom, 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 boom. When you look at an LED or even the incandescents, you'll see the full rainbow. You know? So having all those spikes in the colors, that is part of the reason lots of people hate the lights or cause headaches for people. And that. So, but this is a neat little toy that you can make yourself. I've got the plastic off of eBay, so it's quite easy. It's a fun toy, so you can actually see firsthand what the light is like. You know. When you start going to shop for your lights, there's a few things that you want to learn about. The first one, well, we talked about light spectrum, but you're going to select your light based on the color temperature. And this is built on the scale of Kelvin degree, the Kelvin temperature scale. So incandescent lights with the warm glow are about 2,800 to 3,000 degrees. And those are what the main source of lights that I have brought in to resell to people, because it gives you a nice, cozy, comfy color. In some instances, I want to go to a little brighter white. If you have a kitchen that's based on white cupboards and black countertop and that, if you go to what I would call a neutral white, then it will give it the nice sharp punch. But we want, and this is where it gets confusing when you're looking at suppliers. Some suppliers say neutral white might be 5,000 or 6,000 degrees, where I call 4,000 a neutral white. Because once you get up to 5,000, now you're going to get more, a lot more of that blue haze, and it comes through. And my skin especially, I start to look really sickly. So that's my gauge, is look at my hand under the lights, you don't want to live with that.
Right.
Yeah. It's not too bad. If you're looking at paper, it'll be nice and white. Colors on a picture will be fine, because we do have the full spectrum of colors. It's just the difference on what white is whiter or a little warmer color, right? But 4,000, 4,500, that's where I would say is the max. And just as a reference point, the little solar powered garden lights that you get, they have a lot of that blue haze on it, right? And that's what you've seen. And those are probably the 6,000 and 7,000 degree. But the reason they're doing that is so they get as much light as they can out of the little light bulb with the least power. Right? Because more filtering to get the color down, less light. But if you want to start sitting in a room with that light, you wouldn't want to sit there and you'd be looking at your friend and you're feeling okay when you do that. Yeah. So that's the one thing. Colors. Yeah, and this is one of the, with my company, I'd like to go to a person's place, pull out the lights, put in the different color temperatures, what do you like? You know, I'll be honest, if you're going to spend a fair amount on your lights, I want you to be happy with them. You know, and why spend that much money and go cursing it and thinking that they're all bad? They're not all bad. You know, and I can give you that choice and make a wise decision. Next article that you want to look at, or item you want to look at when you're purchasing, is the brightness of the LEDs. Now, we're quite used to going to the store and buying a 60-watt bulb or a 100-watt bulb. We really know what we're getting. Now we've got the compact fluorescence, and it's 15 and 23 watts, is it? You know, like they jump around a little bit and that. And when you get to the LEDs, it's half of that again. But I've been to the different stores in town, checking out what they've got. They're running 9 watts, mine's running 9 watts. Oh, they're generating 100 lumens, I'm generating 200 lumens. Okay, mine maybe $2 more, but twice as many lumens, twice the brightness. You know? So you have to look for the lumens. Unfortunately, packaging nowadays is starting to, it's becoming quite standard to have the lumens on there. Because the power rating just doesn't mean anything. No. It gives you an idea how much energy you're going to use. It gives you no idea how bright your room is going to be. Right? And with LEDs, it's an evolving technology. It's like computers. It's changing and changing. Every year they're going to get brighter for less power. So you got to base it on them. Lifespan of the lights. Like the incandescent light bulb, well, if you look at the packaging, it's rated at 1,000 hours. And they will sometimes last longer than that. What really affects the life of the incandescent, and most lights, is how much you turn them on and off. Because with the incandescent, every time you turn it on, you get a surge of power going through it. Because when it's cold, there's no resistance. There's, you know, it's like hitting it with a hammer. It's taking a shock every time. Because when do your incandescent lights burn out? The second that you turn them on. And you get the great big flash of light, your dust, right? Yeah. Okay. Compact fluorescents also suffer from the same issue. The more often you turn them on and off, the shorter the lifespan. LEDs, no effect. No effect. Right? It is actually the same technology that you use for communicating on the internet. It's called a laser diode, but it's a light, LED type of light, that's transmitting your signals over fiber optics across the world, and those are switching on and off millions of times a second. I've got dimmers here that work based on turning the light off and on thousands of times a second. So it has no effect on the lifespan of LED lights by turning them off and on. And I had one customer say, well, they're going to do their whole house, but what about in the kids' room? Is it going to affect that? I said, no, not at all. You know, it's a lifespan. We talk about lifespan, compact fluorescents. They're rated 5 to 10,000 hours now. The rating is getting up there, but all the feedback I get from people is they're not making it. Yeah. Okay. The reason, I'll just get this out here. The main reason for compacts failing is they're not designed to operate this way. They'll last a lot longer if you do it this way, because they still generate a lot of heat. These are still running about 125 degrees Celsius Okay, so now you're getting the heat up on top of the electronics in here. And when you look at the burnt out bulbs, they'll always be brown. Always be brown, right?
Yeah.
You know,
I've
so
noticed that.
they're not making it to the lifespan. Okay? The LEDs, most of them are rated 50,000 hours. Okay? And that actually depends more on the electronics inside of it than the LED itself. And when they do design these, it's actually designed to have a maximum temperature of 65 degrees. That's the safe zone. So the electronic components can withstand that a lot easier. And there's different designs, better, see, heat is the enemy in LEDs versus heat is what makes incandescents work. It's the enemy in these. The benefit is 40 below outside in our Saskatchewan weather, instant on. Yeah. And that's where compact fluorescents fall miserably. As outdoor security lights, well, by the time it warms up at 30 below, like,
not much security.
yeah, leave the light off, like it's no point. Right? The other question is that you talk to people about 50,000 hours, you go, 50,000 hours, how long is that? And you go, well, if you're running them 24 hours a day, like security lights, that's still 5.7 years. Okay? But realistically, let's say in a store 8 to 10 hours a day, that's still 17 years. If it's in your basement, you're running them for 4 hours a day, 34 years. Okay, so they're going to last a long time. So you're